My name is Irina Petroviciu. I'm chemist researcher in the National Museum of Romanian History, and I would best describe my work as dyes and textiles from Romanian collections, or even better, how could dye analysis enrich the existing knowledge in textiles from Romanian collections. Local collections are all dated from the 15th century onwards. And the best represented categories of textiles are liturgical embroideries, brocaded velvets, maybe court clothes or top veils, oriental textiles, and more recent traditional textiles. The first dye analysis on textiles in these collections date from 1997, when, lacking the adequate instrumentation as well as knowledge on how to investigate dyes in these textiles, I applied for a research scholarship, which was developed at the Royal Institute for Cultural Heritage in Brussels under the coordination of Dr. Jan Wouters. And this gave me the possibility to familiarize with the use of liquid chromatography for these tasks, and also to investigate dyes in traditional textiles. Collaboration with the Royal Institute of Cultural Heritage in Brussels continued in the following years, and together with Jan Wouters and Ina van den Berge, we were able to study dyes and biological sources in many other textiles from local collections. In 2005, I participated in a common task developed in two European projects, COSG8 and ARCTEC. Within two short-time scientific missions hosted by the Royal Institute of Cultural Heritage in Brussels and the National Gallery in London. My task was to prepare standard dye textiles and standard organic pigments, which were then distributed to the main laboratories specialized in dye analysis in Europe, as well as to the Getty Conservation Institute in the United States. And these samples were then analyzed, and these laboratories critically compared their analytical protocols and eventually improved them, with consequences in better analytical and smaller sample consuming. And of course, all this experience accumulated, as well as the experience accumulated within the participation in the dyes in history and archaeology meetings, gave us the possibility to build our own analytical protocol. And this was possible in 2007 with the support of the Faculty of Chemistry in the University of Bucharest, who hosted my PhD on building this protocol, and with the help of a pharmaceutical enterprise, Labormed Pharma, who provided access to the analytical instrumentation. And this gave us the possibility in the following years, together with the institution already mentioned, and also with Agilrom, to investigate dyes in a large number of textiles from local collections. But how are these dye analyses performed? First, we need a sample preparation step. So we need a sample, which is usually provided by the textile conservator. The sample is extremely small, some milligrams. Dyes may be extracted from the samples by using different procedures. We use the standard procedure, which is acid hydrolysis. After several other preparation steps, the colored solution is injected in the chromatographical system. Within our protocol, we use liquid chromatography with two detectors connected in line, a diode array detector and a mass spectrometer. It may seem quite complicated to explain within this information on the screen, but I think it will be easier to explain with an example. So for a small yellow sample from the decoration in a traditional textile from the Astra Museum in Sibiu, we observed with the first detector, the UV-vis detector, the presence of luteolin. This dye component being observed by retention and the UV-vis spectra as compared with the information previously stored in a database. The presence of luteolin is then confirmed by the second detector, the mass spectrometer, which is even more sensitive as compared with the UV-vis. But unfortunately, the information about the use of luteolin in our sample is not so much useful, as luteolin is present in a large number of biological sources, in many cases together with apigenin, and there are 3 dye sources which played an important role in textile dyeing. And for each of them, it is need to observe the presence of another dye. So while the compounds observed with the UV-vis detector would be considered major compounds, those all we observed with the mass spectrometer, which is more sensitive, as I've previously said, would be considered minor compounds. So detection of luteolin, apigenin, and genistein would clearly suggest the use of diaphragm. Of course, while chrysoiol is present, we definitely observe the use of weld, while the 3-methyl quercetin suggests the use of Sawert. To look even more complicated, these biological sources may also be used together, 2 or even 3 of them. Of course, the flavonoid dyes discussed before are not the only one existing. There is a large variety of flavonoid dyes. Some of them are illustrated on the screen, and they may be present in biological sources in different combinations, as the ones presented here. So why do we consider that it is so important to identify the biological source? Of course, there are several reasons. I will refer today just to one of them, maybe the most important. By dye analysis, we could understand where and when an object was created, so the context it was created, if we consider that initially each biological source was used only local, and only later on it became subject of commercialization, and the moment of its first commercialization is documented as being connected with historical events or geographical discoveries. Putting together the results we obtained until now in, let's say, more than 20 years of working on the investigation of natural dyes, we could observe that we have on one part the biological sources. I will just refer now at the yellow sources as the ones showed before, and we put together here the categories of textiles and as well as period, and we could observe that certain sources such as weld were present in all the groups of textiles and in all periods. In the 2 categories mentioned here, there were only red, so we won't consider them now. While there are some other groups of or some other biological sources, such as bastard hemp, which was only used in liturgical embroideries and only limited to the 15th to 18th century, while we have others such as isparak, which were only in the 19th, used in the 19th and 20th century. Of course, there is not enough time today to convince you with many other sources of information regarding the use of certain biological sources in the groups of textiles and in time. But you should also consider that that it is extremely important also taking into consideration the geographical position of Romania, which is situated between east and west. Even more interesting information would be provided by red dyes. So apart from the vegetal red sources, there are also animal or insect red sources. And there are 4 groups of insect dyes which played an important role in textile dyeing. I will just refer to one of them, which is leg dye, originally from India and China. Its use is well documented in its trade. It's well documented in literature and also confirmed by analytical investigation. What I would like you to observe is that leg dye was only rarely identified in Western European textiles, probably due to the prohibition of its use, as it was probably in competition with the other red dyes present in and already used in Western Europe. What happens in Romanian textiles? The analyses performed on a large number of liturgical embroideries dated from in the second half of the 15th century. I don't know if I mentioned dated liturgical embroideries, as well as on silk threads in document with hanging seals, allowed us to observe that actually leg dye in a combination with madder was the main source used in these embroideries and silks. And it was never, while leg dye was never detected in brocaded velvets, which are of Western origin. Considering that leg dye was very much used in Oriental textiles, including Ottoman textiles, we would suggest that actually materials in 15th century liturgical embroideries have an Oriental origin, and the use of leg dye would point to this Oriental origin for further textile study. On the other hand, literature mentions that Mexican cochineal, which arrived in Europe early in the 16th century, and at the end of the century replaced all the other dyes used in Europe. And all this information was also proved by analytical investigation on later liturgical embroideries. We could assume that leg dye may be also used as a criteria of dating. So I hope this example may be considered enough attractive and convincing for you to understand how much the analysis could help to place textiles in a context. And I would be very happy to share all the information that we have until now on obtained on the textiles in Romanian collection within EuroWeb, and so contribute to drawing some trade route profiles. I also hope that within EuroWeb will be able to better understand how dyes, biological sources, dyed fibers were traded in this part of Europe. I hope to be able to more exactly place Romanian textiles in the European and worldwide complex context, and this would be also performed in connection with the digital class. I also hope to participate and am active in the DICE and dyestuffs study group, which is a subgroup of working group 4. And of course, I'm happy to work together with the Euroweb team in all other tasks we'll see in the following years. Thank you very much.